Back to my channel Valbigyan Bharti, and this is your mentor Avilash Sarkar. Now in binomial series or theory, we'll move to the problem number 43. We have ended it in previous episode. Now I will move to the problem number 44 in this. So there's not much variety is remaining. So whatever comes as a tougher among them, then that we are discussing right now to fulfill our target of 50 problems. So the next comes here 44. So 44, I will take this, the term containing a to the power 5, b to the power 7 in a minus 2b whole power 12. Okay, is which term that you have to decide. Okay, so what we'll do as per our the traditional method of doing that, we'll assume that this term is there in the t plus rth term, tr plus 1th term. So tr plus 1 term, if I want to describe, it will be described as 12cr, 12 is the maximum power, first term to the power 12 minus r, and the second term which is minus 2b whole to the power r. Now we will only talk about this one. So this will be true if 12 minus 5, this one equation satisfies 5, and also this has to be satisfied, means r is equal to 7. Means what is the power of b? If I take this as true, then r should be 7, and at the same time whatever the power of a I am getting by this 12 minus r, that must satisfy 5. So let's see. Now this is the straightforward answer. This is true. Now this, if it is true, this has to be true. So now if I calculate r from here, this also will give you 7. So this satisfied. So r, if it is 7, then only the term I will get like this. So there is not much to be calculated, only they need the term. So term will be r plus 1, that is equal to 8. Now in extension to that, if it is required, what is the coefficient of that term, then the coefficient, it is not there in the question, but still I am saying, if it is extended in any question, that you find the coefficient after finding the term which contains this one. So the coefficient will be 12c7. A and b is supposed to be your variable, so we'll leave it as it is. The coefficient will be minus 2 whole to the power r. So this will be your coefficient. Now further, if it is needed, you can elaborate or extend, or you can simplify this to get the required answer, or if you keep it like that also it will do. Only thing you can do, that what is the outcome of this minus 4 to the power 7, that you can take it out, because minus of 4 to the power odd will be minus, then 2 to the power 7, and ultimately you can keep the answer in this way. Okay, need not to elaborate this. So this will be your answer. Okay, so moving to next. Okay, now 45. Okay, 45, if I take this, let the coefficient of of x to the power n in 1 plus x whole to the power 2n and 1 plus x whole to the power 2n minus 1 be p and q respectively, then find p plus q by q whole power of 5. Okay, so okay, let me find the p and q value first. The coefficient you have to find. So anyway, by seeing the series, if I see this series, generally we have explained or expanded so many types of similar series. If I take this as also the another series, so now in any case, whatever be the number of term, x power will be 1 less in that series, because if you see the first term is 1 without x to the power 0, second term is carrying nc1, x to the power 1, so the second term getting 1 less power of x. So in that way, x to the power n, if I want to find in this, your coefficient will be 2n c n, that will be the coefficient, because whatever there in the bottom, it will carry over to the x power. And if you see this, if I want to get x to the power in this, so my coefficient will be n plus 1 then, because the highest power will be 2n minus 1 c, and here if I want to get x to the power n also, in that case also this will be ncn, 2n cn, because whatever be there, it will be the power of x there. Okay, so this is t n plus 1 term here, this also t n plus 1 term here, both the case, because n plus 1 term only will get cn and x to the power n. Here also the similar term will get, because the second term is x 1 power less, so the term will get x to the power n, that also to be n plus 1. Understood? But the highest power, the extension of the series will be of 2n terms here 2n plus 1 term. That's it. The number of term will be one high than this. So this is the only. So there should not be any ambiguity during doing that. One should not be fell into trap that as it is 1 less, so x to the power n will get in one higher term there. So there you can make mistake. So this is the thing that you have to be choose very cautiously. There are always a chance of getting it mistake, that people may compare in such a way that as we are having 1 power high, we will get in n plus 1 x to the power n. Here I will get the same thing in n plus 2 term. No, because this represents, if it is tr plus 1 in generic term, we know it is ncr and x to the power r. This power and this will match with the thing. So this does not depend on the highest power of this. This may be anything. Accordingly, it will come there. But this will not affect the rth term, because rth term is a generic term that depends on the what we take there as r plus 1 or what r plus 2. Accordingly, it will change there and the power of. So in both the cases, the term is n plus 1. So this is fixed. So what we know, this is equal to P and this is equal to Q. Now this we can break into P by Q plus 1 whole to the power 5. So what we have to do, P by Q first we have to calculate 2n Cn and 2n minus 1 Cn. So if we break 2n factorial, n factorial, n factorial, and it will topple, it will go ups and down. So the thing will come here at the bottom, 2n minus 1 factorial and 2n minus n. So this will be n minus 1 factorial 1 and n factorial will come. Okay, n factorial, 2n minus 1 minus n, so n minus 1 factorial. So now n cancelled out and this will become 2n, means 2n will come up and here n will come below. Okay, so now this n, because if we keep 2n, the next will be 2n minus 1 factorial, and here along with that n minus 1 factorial will go, and if we keep n, so n minus 1 factorial will come there. So bottom 2n minus 1 factorial is already there. So this will cancel, remaining 2n by n, so n also cancel, you will get 2. So if we put 2 here plus 1, it will give you whole power 5, so 3 to the power 5. You need to expand it, or otherwise you keep it as it is. Okay. If there is a choice where it has to be simplified, you simplify, otherwise this will be the last answer, you will get full marks for that. Okay, understand? So there is the trick what will take. Okay, so otherwise you can make mistake. If you go with a similarity without thinking, you may distract and you can get here something, what you take n plus 1, n plus 2, so you will make mistake, because you follow this thing will carry over to the x power. So to get x to the power n, this must be n. This is the only simple thing that you can think. Okay, I will move to the next problem, number 46. The next problem is number 46. So the number 46 says, in the expansion of x cube minus 1 by x square whole to the power n, where n belongs to natural number, if the sum of the coefficient of x to the power 5 and x to the power 10 is 0, then find n. Okay, so let me take the common term is r plus 1, where r plus 1 is equal to, in generally we write it like that, where x cube whole to the power n minus r will come and minus 1 x square whole to the power r. So what we'll do, we'll put all the things one side and power of x in one side. So this is 3n minus 3r and this minus 2r will come. So all together this will stand like that, ncr x to the power 3n minus 5r. Now this is generic term. Now both cases, if I equalize this as x to the power 5 and x to the power 10, R should cannot be same. R must be a different value. Okay. So if I equalize the first case where 3n minus 5r is equal to 5, so this we are taking as R1. For R1, this will give you x to the 5. And you can understand there is n is unknown, R is also unknown. You cannot solve to get R1. So you have to put like that. So R1 in terms of n, it will be something like that. And the same, if I equalize 3n minus 5 R2 this time, I can say it is 10. So R2 will be in similar way, will become this. Okay, fine. Now what are the other conditions? The coefficient of the x to the power r. The coefficient will be this part where for x to the power 5 I will take R1, and for x to the power 10 I will take R2. So if I put like that, R1 NC R1 plus this will be R1 plus minus 1 whole to the power R2 NC R2, it's said to be 0. This is condition. Fine. Now see, if I see these two terms, this will not give you anything to decide the negativity or the positive of the term. So this will not decide. This is always positive term, I mean to say. So now if this will give you some value, this will give you some, and this will only give you the signature. This will not affect the value, because minus 1 anything, either it will be minus or plus, it will not affect the value. So the value together it will give you 0, and this will give you the sign. So now I understand value must be same, one thing, because two positive thing cannot give you 0. So one should be something, other should be negative of that, and negative will be affected by this sign. So if I say that R1 is even and R2 is odd, or vice versa, then only this equation is possible, where this will only give you the value and value must be same, and this will give you the signature, and signature must be opposite. For any value of R, if it is even, R2 must be odd to give it a negative, and this is giving a positive, or vice versa. This is even, this is odd, or this is odd, this is even, alternate sign, and this value must be same to give 0. Okay, so now if it is understood and accepted, then what we can say, ultimately NCR1 equal to NCR2, that we can say. And this condition only possible if R1 is equal to R2, or the other one, if R1 is R2 is possible. Is it possible here? Because R1 R2 represent two different power of x, so this must not be equal here. So what are the other possibility? The one and only possibility is R1 plus R2 is equal to n. So this is my another equation where I reached from this logically. So now if it is so, now there are one R1, this is R2. If I put it here, whether we will get something or not, let us see that. So now ultimately 3n minus 5 by 5 here R1, and R2 is 3n minus 10 by 5, this is R2 is equal to n. Okay, or this 5 is LCM, 3n 6n minus 5, this is 15 is equal to n, or 6n minus 15 is equal to 5n, or if I bring n this side, it will be n, and 15 this side. So you can see n is equal to 15. So value of n has reached here. Understood? So I will end up here. In the next video, remaining 4-5 problem I will finish it up there, and there will be end of the binomial theorem. So thank you for now. Good night.